for the Angular team. So our team includes myself, Rob Wormald, Minko Getchev, and really we have two missions. First is to help developers be successful with Angular. So really helping people understand, okay, how do I use these things? Why do they work this way? Being productive, understanding how to do things like governance, all those kind of wonderful things that are necessary to be an effective engineer. And the second part, and almost more important part, is to represent the needs of the real world onto the team. So listening to and understanding and actually building applications so that as users of Angular, we get the appropriate sorts of reflection from everyone on the community, because that's how we make good decisions in the long term. So we're here to talk about a little bit about RxJS, and I actually have an interesting history with kind of both Angular and RxJS. So when people first started introducing Angular and RxJS to me, I was a little bit frustrated. I got into starting learning about observables, and I thought, wow, this is really complicated. This seems super frustrating. I hate this. And I felt like that for probably a few weeks until I built a few different applications. And there was a day that came where I was building a new component into my application, and things started to click. Sorry, I'm fighting with my room here. And what happened was I started to see how RxJS was empowering me a little bit differently. So instead of thinking about observables as this kind of mess that I have to untangle at the component level, I started to think about them more as an assembly line, where I could have a data source, like an HTTP request coming in, and then at several parts of my application in different services, in different kind of centralized layers, I could just do one thing at a time to that data. So for example, in my data service, I would transform the data, maybe unwrap and remove the status headers. And then in a different part of my application, I would reformat that data to match what a component expected. And another part of my application, I would be handling retry and error handling. And so I started to see that using observables, I could actually handle each things in a very isolated, very controlled manner. And this was kind of a very magical moment for me. If you've seen the very old movie now at this point, The Matrix, there's a moment for them, characters in that universe, where they can start to see beyond just the code. And I think that's a moment that comes for a lot of people, that when they start using RxJS, is you start to see, okay, there's streams of data that's coming into my application, and then that stream eventually is going to result in some sort of user experience or some sort of interaction pattern. And that makes a lot of sense and kind of makes things very, very valuable when you start to get that. So I want to help everyone here take a step towards that goal. So first I'm going to start off talking a little bit about how we use RxJS in Angular, a little bit about why we do that. And then I want to talk generally about change detection as one of the kind of main drivers. I'll touch briefly on promises versus observables. And I want to end up by actually empowering everyone here to start building your own operators, which is a key part of using RxJS effectively. So let's start off talking about how the Angular team uses RxJS. So RxJS is actually a dependency if we use it in Angular itself, and we expect developers that are using Angular to, at some level, be interacting with RxJS. And there's a number of different places that you're going to see this. You're going to see this in our event emitters. So anytime you have a component that's going to be sharing to a parent component via this kind of event system that mirrors the DOM, we use something called an event emitter, which is actually just a thin little wrapper on top of an RxJS subject. You also do it in libraries, for example, like our router. So if you are trying to access the route parameters, you can access that via the params or the param map that's going to be coming in as an observable to you. If you look at why we did that, it's actually kind of nice. It's a performance optimization where if you are navigating within multiple routes that route to the same component, we don't actually have to tear down and build up that component. We can just say, hey, component, here's some new data. We do this in HTTP, and I'll explain kind of a few of the reasons why HTTP is an observable instead of a promise a little bit later. We use it in our router if you want to listen to the events, so navigation end, navigation start, all those sorts of things. If you're doing reactive forms development, you can listen to value changes as an observable. And then anyone that's getting into state management is also going to be probably using RxJS. So if you're using NGRX, NGXS, those sorts of things, you're going to be getting into a more reactive, more functional way of thinking about your application. We also have a pretty good guide on Angular.io, so Angular.io/guide/observables. And they give a bunch of examples where, things are easier to implement because of RxJS and because of observables than they would be in any other technology. So they've got examples like type ahead. They've got an example where they wrap geolocation. So if the coordinates of a user change, how do we actually consume that information? And they also do a very cool exponential backoff example, which I'm happy to talk about a little bit later as well. But really, to understand why Angular is using observables in RxJS in a bunch of places, it can be helpful to think about change detection, as this is kind of one of the main drivers. So all the way back in AngularJS, we had a change detection process that basically looked like check everything because anything might have changed. And we checked everything anytime there was a user interaction, anytime there was a anything that happened in your application. We basically had to check everything because we did not have a way of knowing what parts of your application could affect other parts of your application, and we allowed change detection cycles to have side effects. And so basically we had to check everything, and if anything changed, we had to go back to one. And so we would basically run this digest cycle until things stabilized, until there were no more side effects. And this was really, really inefficient, right? If you had hundreds of watchers or thousands of watchers or complex interactions between your code, this meant that Angular change detection was very, very slow. And so when we were rewriting into Angular, we did a few things. So we moved to a tree model, so a component-based tree model. Change detection starts at the top of the tree and goes down, and we only have to check any component once because we know that there are no side effects. And even better than that, you can actually make a selection in terms of your change detection strategy that you can say only change check the components and the component subtrees that need checking. So if you think about your tree of components, we can actually say at that third node there, hey, this part of the tree only changes when one of our inputs change or when a we actually manually kind of mark it for check. And so the nice kind of side benefit of that is that you don't have to check any of the subtree, which makes change detection very, very fast in Angular. And that's one of the features that people tell us that they like the most. And when you think about how that works and how change detection works, there's actually this communication that has to flow, right? So you've got some part of source data, whether that's coming from an HTTP request, a WebSocket, some other part of your application, but you have some source data. And then throughout your application, you're going to apply a bunch of abstractions, you're going to apply transforms, you're going to create services that manage that data. And then the template is going to eventually consume some version of that data. And what's happening here is that you need your template to be change detected anytime the source data updates. And this can be a little bit complex if we don't have a clear understanding of how that source data maps into that template, or we don't have a clear chain. To really dig into this, we have to understand a little bit about how promises work and how observables work. So a promise, a lot of people use promises, but you basically have an asynchronous process that gives a promise back synchronously, and then you call the then method, which establishes the callback effectively, so that when that promise resolves, when the asynchronous process is completed, you then perform a method that you supply. And we have a very similar version in observables where you subscribe to an observable, and then every time that observable emits, you can run some resulting function. But we often find, especially in kind of modern JavaScript, that promises aren't enough. Promises are basically simple they allow you to consume the results of a single process. So you will only ever get 0 or 1 results back from a promise. Whereas an observable, you can think of it as more of a process that is extensible. So when you call promise.then, you're saying, as soon as this completes, do this one thing. Whereas observables, you're able to pipe them, and you're able to chain them, and you're able to modify them in a way that doesn't actually execute the process or even specify what to do when it completes, but you're creating another step in a chain. And I'll give some examples of that. One example of that is retry. So in a promise, you aren't actually able to control what's happening in the process. Whereas in an observable, you can actually pipe it with the retry operator that then is going to effectively allow you to do something from your template or from your component that's going to modify or change the behavior of the source. So if we take a look at a quick code sample here, so as I mentioned, we have a data service, and we're calling the then on that promise. We can have a result, and we can handle that however we want. And we can catch errors, but the only way to fix that error is to actually go all the way back to your service and reinitiate and recreate the promise and then start listening to it again. And this is actually kind of awkward when you want to do things like retry. So if my HTTP request fails, I want to do something different. With promises, that's a very complex process. Whereas if we contrast that with observables, what I can do is I can just say, hey, I have an observable in my data service, and I can actually just call the retry method. You can pipe that through retry. And then what happens is your template or your component is actually saying, hey, I need you to reinitialize your process. And that will actually pipe all the way through all those transformations, all those abstractions. And this can be very, very powerful because your component doesn't actually need to know where the data is coming from. It can make these higher level ideas and concepts like retry, and then all the observables and all the operations along the way are going to handle that effectively. We also see that because observables allow us to represent repeated data as opposed to just a single result, we're able to better reflect a lot of the things that exist natively across the web. So obviously user interactions, right? A user might click on a button once, but they might click on that button 30 times. They might perform many different actions multiple times that you want to handle in different ways based on the context at the specific time. Network requests, we traditionally think of HTTP requests and XHRs as single response, but we're seeing more and more times where we actually want data to come back multiple times. One of the examples that I see a lot in web applications and mobile applications is the idea of a refresh button, right? You want the user to be able to refresh the data at their will. And then we also see things like WebSockets, which are used awesomely in tools like Firebase and Angularfire, which Katerina is going to talk about. Oftentimes we have timers, so maybe we want to do some sort of process in our application every 5 minutes. And if that process has any impact on the visual representation of our application, being able to have all of the data automatically update whenever those timers trigger, that can be very helpful. And then we also are seeing more and more threading. So where developers will actually put part of their application into a web worker or another thread so that they can do some sort of heavy lifting that then returns some sort of result that they are going to act upon. So observables are really, really important to think about as streams, where instead of having to update 0 or 1 times, your template actually shouldn't care about how many updates there are. And the nice part about this is if you can handle kind of n updates, if you just assume that you're getting in a stream, then even if someone just wants to return to you a promise-like object, like an HTTP request, you can handle expansions to that promise or expansions to that single result very, very easily. Another really important difference is the idea of cancelability. So promises, once you've created a promise, it cannot be canceled, right? There's no feedback mechanism between your component that's consuming the promise and the source data. Whereas an observable, because the consumer is actually the thing that's controlling it and initializing it, you can actually unsubscribe, which cancels a process, which means that if you have, for example, 1,000 HTTP requests and the user navigates off the page, we don't have to load those 1,000 HTTP requests, which can have a bunch of performance benefits, as well as you can represent this with more complex processes. So let's imagine you had a observable that was doing some sort of, as I said before, kind of heavy data processing. Maybe you're doing some sort of mapping or navigation. If the user does something and they cancel that process, it's very, very nice for the consumer of that data or the consumer of that information to be able to just cancel that and kind of short circuit it. So to really understand how RxJS can be super powerful in your Angular application, I want to walk through how you can actually create some of your own operators, because this is a very scary idea. I've had a few senior, very experienced developers come to me and say, wait, you can create your own operators? But you might be thinking, do I actually have to do this, right? Like, RxJS can already be sometimes very scary. I have not yet decoded the matrix. I don't quite understand the reactive way of thinking. But I would actually say yes, you're going to probably need your own operators either at some point in the near, medium, or long term, because every application at scale needs these for a whole bunch of different reasons. One of the first reasons is that operators are just like methods in a little bit. So here is a complex piece of code that I found where you've got a query that's going on that's creating an observable, and then they're piping that through a merge map that goes to another service that pipes another thing. This is a very, very complicated piece of code, and all of this code is inline. So at the point where I'm making the query, I'm also handling all of that data. But if you had a method that was very complex, that was doing a whole bunch of things in an asynchronous pattern, you should probably abstract those methods into nicely named, isolated, smaller functions, and creating operators allows you to do the exact same thing with observables. So imagine if you'd taken all that custom code for the piping, the switch map, the additional fetches, and you wrapped those as a single operator. You could separate the code that's consuming that query and the code that's creating that query, so that you just say response equals response.pipe, and then apply your custom query. So in a way you can think about this as kind of by writing more or better RxJS using the ability to create custom operators, you can actually end up writing less RxJS, because one of my goals is always to keep my components and my templates as simple as possible, where I don't want to be doing 500 lines of data processing at the component level. I want to do that higher up the chain, so that my template is just doing one thing and it's rendering data, and I can do that very well. And this actually allows me to remove a bunch of the different pipes and operators that I need to do just by having that level of abstraction of a custom operator. So there's a lot of different reasons you should build, or places you should build an operator. If you ever have these repeated patterns, so let's say you're taking every HTTP request in your application and you're handling errors or handling retry, maybe consider creating an operator. Obviously, anytime you do shareable behavior, so if there's some sort of custom processing that you're doing on all of the data that's coming back, that's a really great place to do operators. But even just getting isolation, where you can separate the functionality that's happening in an operator from the rest of the application, can be very powerful. And anytime you're doing several operators, it's kind of hard to test those. So oftentimes we see that people want to pull out and abstract those operators into a custom operator that can be tested in isolation separately from the actual data that it's processing and the usage of that data. There's a fantastic website, rxjs.dev/operator decision tree. So if you don't know what operator to use, or if you're wondering if something already exists, I definitely recommend you go here and actually follow the flow. It will point out some operators you might not know exist. And this can be an input to the decision of, should I build a custom operator? If you're going to build a operator, every operator has basically a very simple signature. It takes in a source observable of some type and returns a observable of another type. So it's going to, maybe you subscribe to the source and you create a result. And when you chain these into a sequence, what you're actually doing is you're taking an observable type A and you're turning it into B, B into C, C into D, and then at the end of the pipe, you now have an observable of type D. Let's actually take a look at an example of this. So if I was to take some data, so I've got my observables, which is a source, and maybe I want to unwrap it. So I'm maybe querying a GitHub API, which has a bunch of kind of intermediate and status properties, and I want to just get the data property out of that object. I can do that with a map operator, and then maybe I want to share that operator so we don't make multiple HTTP requests, so I share replay, and then I want to take until, and I do this.destroy. So what you're doing here is you're taking that my observable and you're turning it into a new observable that maps the data, and then you're turning that new observable, that second observable, into a third observable, and that third observable into a fourth observable. And this sort of pattern is very, very standard. It's very, very powerful because then the resulting observable of this set of operators can really be passed around and used anywhere, and then you continue to compose these things very nicely. When you're creating your own, we find that operators are usually parameterized. So instead of just having a function that takes a source and returns a result, oftentimes you'll have a function that returns a function. So there's kind of one layer of indirection to be aware of here. And anytime you look at a custom operator or any of the existing operators in RxJS, you're definitely going to see that pattern. So an example of this is, let's imagine I have a repeater. So I want to take some observable and I want to repeatedly listen to that. So you can imagine this, I could use this to automatically refresh all of my HTTP requests every 5 minutes or every half an hour so that my users always have the latest and greatest data. So we define a repeater here that takes in an interval, and that then returns a function that is that operator that takes a source observable and returns a resulting observable. So composition is really the most common pattern, and I think composition is the thing that most developers should look at and is going to be most useful. Because basically what you're doing is you're just reusing and combining existing operators, right? We've got all these really great operators. We have to use them all very often, and sometimes we can simplify things by composing them. So if we have a map, we have a filter, and we have a share replay, I can actually combine those operators so I don't have to do that in my component, and I could create a new operator. So maybe this operator is called share unwrapped. And then that actually simplifies any place that I'm going to be consuming that data, because I can just pipe in my operator instead of having to do that entire chain over and over in different parts of my application. I mentioned the testability of custom operators as being far superior than trying to do this in your component where you're actually consuming the data. So here's an example of if we took that share unwrapped operator and we wanted to test it. Because it's a separate operator, we can actually do it in isolation with just test data all locally here. So we say create an observable with results 1, an empty object, results 3, and results null. And then if you remember, our operator actually both gets out the results object and filters out anytime that the results object doesn't exist. And so out of this set of those 4 values that are emitted from the observable, we can test to make sure that we're just going to get out items number 1 and 3. And we can do that entirely isolated from our component, which is a really best practice, and we'll make sure that our tests are less fragile. So there's a whole bunch of common use cases. We've talked about a bunch that exist in Angular, but I want to talk about things that actually live in your application that you might want to go and build custom operators for, and where you are going to start receiving a lot of value for RxJS. One is error handling. Most applications have some level of error handling. When you start to get to a certain scale, you want to have a standardized way of responding to problems in the application. So maybe you have a log error function. So this is actually an operator, right? It's going to return catch error, which is going to take an error. It's going to console log it, and then it's going to return some sort of like empty value saying, hey, we've acknowledged this. And what you can do is you can just use that operator and pipe that into all of your HTTP requests, and then all of your observables in your application are going to automatically be logging those errors in the right way you want to do that. Maybe you're sending up some performance data as well to your server, all in that abstracted place, instead of trying to catch all of the observable problems that happen throughout your application. One of the common patterns that I see is, as I said before, that refresh button. And so one of the things that you can do is you can have a observable or a subject that exists in some service somewhere. I call that a refresher. And you can actually take that in as part of every observable in your application and then switch map via this operator we're creating called refresh upon. So then anytime you want to actually use this refresher, you can just wire it up. So when you make an HTTP request of getting my data from some sort of source, you can hook up that data source to the refresher so that anytime the user hits the refresh button, every HTTP request, every piece of data that you're rendering to the screen throughout your entire application is going to automatically get refreshed. And this is a really powerful thing, because if you think about trying to wire that same thing up manually, either with a local state or with promises, that would really be a nightmare, right? You would have a button click on your refresher that you now have to go and reinitialize all of the promises. You have to go back to your data service and say, please build all those things back up. And then you'd have to go listen to all those, and you'd have to promise .then in all those different places, or update all the local state. But this is a much cleaner, much nicer way to share that refresh across an entire application in a seamless way that's going to render perfectly to your templates. So composition, we're really breaking down complex functions into simpler ones. Even just giving something a name can be really helpful. I've seen a couple examples where someone was doing a complex map operator and they were transforming some piece of data into another piece of data. You can actually create a custom operator that just does that single map and give it a name. And then people that are reading your code are going to have a much better understanding of what that operator actually does. When you compose operators, you're going to create code that's more reusable and, as we saw, more testable. So sometimes you do want to create one from scratch. So I'll just this code is unattributed. I think I made it up, but I'm not sure. To create an operator from scratch, one must first create the universe. Little riff on Carl Sagan's apple pie quote. First question I always have is, are you actually sure? Definitely go take a look at that operator decision tree. There are lots and lots of really good operators with better tests than you will probably write. More time, more energy, more eyes. Anytime you can reuse an existing operator, it's probably going to be very, very helpful to you. But if you do have to build a custom operator, it looks a little bit like creating a promise. So I'll just say we showed before how we have to take in a source observable and return a resulting observable. How you can do that looks a little bit like promises. So in a promise, what you would do is you would say you take in a resolve and reject function when you create the promise, and then, for example, you call the resolve method. When you create a operator, you are going to be returning a new observable that's going to take a subscriber, and then that you can call the next on that subscriber. So then, for example, you could theoretically be listening to the source observable, and then when the source observable does something that matches some sort of behavior, you then let your observable, your subscriber, call the next method. here's what a very, very simple operator from scratch might look like. So let's imagine we were trying to rebuild the map function. So we are defining a operator here called map that is generic on two. So we've got a source observable of some unknown type and a result observable of some unknown type, right? We don't actually know those. It's based on the function that we're given. And then I'm going to return a function that takes in that source observable, returns a new observable. And then in that new observable, all I'm doing is I'm subscribing to the source and then passing on those values. Whereas or in the next method, so whenever the source observable emits a new value, I'm calling the function on the value and then emitting the result of that function call. So hopefully, once you understand the parameterization at the top and then what we're trying to do of taking an observable and return observable, this makes some sense. But again, don't try and rebuild observables. Whenever you want to, whenever you can reuse an existing one, it's going to be far more effective. Because this operator is actually incomplete. Because what happens if the function throws, right? We might actually be hundreds of necks deep. We might be going through other operators, we might be going through other functions, and the stack trace might not actually be useful for that function error. And if we drew a kind of a naive try-catch, that would cause problems. And also, we're not doing any sort of cleanup. So we're not unsubscribing from the source, we're just kind of failing, which means that processes that might be long running might keep running, and that's not desirable. So when you think about creating your own observables, there's a couple things. There's hot versus cold observables. So by default, as I said, you're operating on the process level. You're not actually operating on data. So when you create a new observable, when you create an operator, you're not actually, the observable that you're creating is not guaranteed to run unless someone starts listening to it. And so that's generally called a cold observable. But if you're doing all sorts of subscriptions in your wrapper around that observable, you might accidentally make it hot. So you might accidentally trigger all the functionality even when nobody's listening to your custom observable. So that's something to watch out for. And then as we looked at with map, there's a lot of edge cases where what if the source is null? What if we don't know the typing? So there's a lot of edge cases to worry about when you start doing these things from scratch. So I want to end with kind of this way that I think about how RxJS can be very, very powerful for developers. At some level, you should be going through a whole bunch of processing, combining data sources, multiple API calls, local state, user interactions. You combine them, you reformat them, and at some point they should get to your template. And ideally, they're going to get to your template and your component in a perfectly formatted source, so in exactly the shape you want. And then in your template, you can just subscribe via the async pipe, which kind of unwraps and unrolls it. And what this does is this keeps your component super clean, super isolated from all of the abstractions that it took to get from your data source to that point of rendering on the screen. And this creates a really maintainable, really clear, really isolated separation of concerns, and really just a better application overall. Thank you so much. You can follow up with me if you have any questions on Twitter, or let me know what you thought.
Thank you so much, Stephen. We really appreciate it. All right. Katerina, are you ready to go?
Yes, I'm ready to go.
Yay!
Okay, let me start sharing my screen. So, share. Can you see my screen?
Yes.
Present. Can you hear me? See my screen? If I do like this, you can see everything, right?
Yep, you can see it all.
Okay, good to go.
Take it away.
Yeah. Hi, everyone. I'm Katerina Skroumpelou. And today we're going to talk about Angularfire, which is a library that connects Firebase and Angular. I'm a Google developer expert. Okay, let me put this here, I guess. I'm a Google developer expert for Angular. I'm a software engineer at this dot. I'm the co-founder of Angular Athens, which is the meetup for Angular in Athens. I love web, I love Angular, and I love cats and chocolate. There's a lot of things I love. And I am from Athens, Greece. So this is Athens. I have to show a picture of it. I don't know where all of you guys are from. So what's our agenda today? Today we're going to talk about Firebase and Angular, as I said, and the thing that binds them together, which is Angularfire. But in order to talk about this, let's think of a scenario and why you would need to use Firebase. So a modern day scenario would be that you have an online business and you would want to scale. You would want to have users and dynamic data, users to write reviews, for example, or post photos, users to be notified of new things that your business, I don't know, puts out, or you would want users to refer friends, or you would also need search engine optimization for your single page application. So you would go with server-side rendering, I guess. What you don't have is a backend developer and a server, which seems like quite of a problem. But luckily, we have Firebase to solve that. So what Firebase offers, some of the things it offers, and we're going to touch a little bit today because we don't have that much time. Let me look at my timer as well. Is authentication through various providers, which we're going to see in a while. You get a database, which is real-time and it synchronizes data across all the platforms that you have. You get your storage that you can store images or other forms of data. You get hosting. You can have push notifications using cloud messaging. You can have server-side rendering. And you can have custom links for example, user referral and also hosting of these links. And a lot more of things which we're not going to talk about today, which is pretty awesome, right? But does it work well with Angular? Of course it does. There's Angularfire, which Angularfire is the official library that ties Angular with Firebase. And it offers bindings for all the things I mentioned above, for authentication, deployment, Cloud Firestore, Cloud Function, messaging, so you get push notifications, performance monitoring, storage, and server-side rendering. And they're all of these are made simple with Angularfire. And here I want to give a shout out to my best friend, Jeff Cross, who is one of the creators, among other awesome people who contribute regularly. So let's get started. Let's get serious. How do you add Angularfire to your Angular project? First of all, the simplest thing you have to do is to install the library, and which is Angularfire and Firebase, and then initialize the module in your app module. So first of all, when you add Firebase to your project, you have to run Firebase init. Let's see this video here. And this will create a number of, let's go a bit more slowly. This will add a number of things to your project. And you can choose to add, for example, as you can see here, Firestore, which is the database. You can add hosting and cloud functions, which we're going to use for messaging. And then you are configuring your project. First, you set up your project on Firebase, and then you configure it from the command line, which you're going to see in a while. And after you have run all these options, you get a ready-made project that has Angular and Firebase all installed. So let's see a little bit of the code. I will spare you, I won't show you a lot of code. So for example, when you install Firebase, you have to add in the app module the modules that you're going to use. First of all, the Angularfire module, and initialize it, and then add each individual module of everything you're going to use. So for this demo that we're going to see in a bit, we're going to use Firestore, which we're going to explain what it is, the authentication, and messaging. So step one, after you add the Angular to your Firebase to your Angular project, is authentication. So first of all, let's see the Firebase console. First of all, you have to go to the Firebase console and enable the authentication. So after you create a project, and we have here the modern web demo project, which is in the Firebase console, and you go to the authentication tab, you choose a sign-in method. And as I said, you get a lot of different providers. For this particular example, we're going to use the Google authentication provider, which is one of the easiest things to set up. And you just enable it. And then each user that signs into your application, you get your email here. These are 3 of my emails. So after you enable authentication in the console, then you enable the authentication module in Angular, and then you in your app module, and then you go in your component, you import the authentication, and then you create 2 methods, the login and logout, that will trigger the sign in with pop-up method from the authentication of Firebase, and will ask for the Google authentication provider. So how would this look? Let's go to an incognito tab and go to my demo app. And you can log in with Google. And it's the normal thing that you always expect when you're trying to log in with Google. And you choose one of the existing accounts, which now with I don't have. And when you sign in, you're signed into the application. And then you have also a sign out button. So let's move on. The other extra thing that authentication offers is root guards. So you know how in Angular we have the root guards, and we can ask if we're authenticated or not, or our user has a certain or is of a certain type or group. The great thing about Angularfire Firebase authentication and the Angularfire auth guard is that it binds to the different states of the user that Firebase offers. So this is from the documentation of Angularfire, and I have the link in the end of the slides. So you get access to all these different states of the users, and you can actually add this to your root guards, which is pretty awesome that you might want to show different messages or redirect users to different places if they're verified or not, if they're anonymous or not, etc. Getting and setting data, the next step. So Cloud Firestore is a fast, fully managed, serverless, cloud-native, NoSQL document database. What does that mean exactly? The great thing about Cloud Firestore is that it is a database that is very fast, is real-time, it synchronizes data across all devices. And what does NoSQL mean? It means that you can have different types of data in the same nodes, and it's actually not relational, but you can run very fast queries and run shallow and deep queries on your data. And Angularfire and Firebase offer a number of ways to query your data. So, for example, if you go to the documentation, which is not here. You can run queries to the data that you have to sort them, or choose a specific subfields of the data and query against them. So, for example, in this application that I'm demoing today, which is a simple chat application, you have data that looks like this. So you have like a parent node that is called messages, and then you have IDs, and then inside messages. So you can sort these and query them. For example, in our application, we're creating a simple query here that we're accessing the collection named messages from our database. And we are ordering the data that we receive by our timestamp and descending. And the good thing is that it works pretty well with observables. So the thing that we're getting back here, first we're getting a reference, and we are subscribing to this reference with this command here, this method here that's called value changes. And this actually is an observable. So the great thing about this is that we can link this here, and in our template, we can subscribe to it with the async pipe that Stephen mentioned before in his talk. So we can actually get here all the messages. And the great thing is that Since it's an observable, each time somebody posts a new message, we receive it instantly. And we don't have to re-request anything, or because it's an observable, and Steven described what observables are. So let's see how it would work. So here, because I was testing, you can see a lot of messages, but this is the latest message, and the instance you posted, it appears here because we have an observable that is watching for changes. But the queries that you can get with the Firebase and the Angularfire existing things are somehow limited. So you can always query one single node to get things from it, and it doesn't work like SQL, where, for example, you can use the relational nature of it and do compound queries and get some data from here, combine it with some data from there. So the native existing methods that Firebase offers and Angularfire offers do not cover that. So what if these don't work for your needs? And actually, I ran into such a problem with the current client I'm working with. We needed, for example, to combine some data from various nodes in our database. What can you do? The good thing with Firebase is that it offers cloud functions. So cloud functions are functions that run on Firebase servers and in the cloud, as their name says. And you can actually request, and you can actually make a request from your client to these functions. And because they run on Firebase, you can actually run more complex operations and actually end up with combining different data that you want and offload, take load off the client. So yeah, cloud functions can really help you extend the existing queries and change things. Another great thing is the push notifications and the cloud messaging that Firebase offers. I'm not sure if you saw that when I posted a message here, I got a push notification. So if you want, you can also go to this address and try it out and subscribe to notifications and see how it works. And I'm going to explain how I did that. So it's modernweb-web-demo.web.app. So for that, I'm using cloud messaging. So in order to establish push notifications on cloud messaging, you have to do 4 things, and we're going to see how to do that. First, you have to request permission for the user in order for their machine to be able to receive push notifications. Then you need the user's device token. So this request of permission is going to get their device token. Then you're going to save the device tokens in FireSource so that you know which devices are subscribed to the notification, and then write a function to send these notifications. So for example, let me bring this here. For example, we have 2 buttons here, send notification about new things and delete my token. The send notification, when you click it, it requests permission. And what it does is it requests permission from the user. And Firebase, actually the Fire messaging module offers a request token method that is ready-made for you, and it actually gets the user's device token, and then we save it here. And if a user wants to stop receiving notification, they can just delete their token. And what else you need to do is you need to have a service worker that will take care of push notifications. Thank you. And try clicking that notification too. And the last thing you do is you write a cloud function. So when we first created our application, I'm not sure if you saw that apart from the Angular application that we have, it also generated a directory that's called functions, which has an index.ts. And in there, we can write a Firebase function, as you see, and it's in a separate file. and it gets deployed with your app when you deploy it. So we write a send notification function. And the most awesome thing is that we can subscribe again to changes on that node. So in order to send notification, we have the Firestore, we have the Firebase function that listens to when this node is written to. And when this node is written to, it triggers a function to send messages to all the devices. And it sends messages to all the devices by accessing each individual token. So this is pretty awesome because each write we write to messages, this function is triggered, and the notification is sent. Where are my slides? Here. So this is what we saw now. How do we display the data? Well, we explained how we display the data. We subscribe to data updates, and we subscribe to them with the async pipe using Angularfire. Now hosting. How does hosting work? First of all, we build, and then the command is as simple as that. We just write Firebase deploy, and then it deploys everything that is related to Firebase, either that it has just the hosting or the functions, and I don't think I have to say any more about that. So what about server-side rendering? I'm not going to go deep into that because I haven't tried it myself. But the great thing is that otherwise you would have an expressor running, for example, and when your page would be requested, it would get pre-rendered. The cool thing is that you can do exactly that with Cloud Functions. So you can see that when your page is requested and have that Cloud Function take care of that and not have your own server running. So you can go to that link that I showed you before. So some questions here to discuss. Does this scale? The good thing is that it does scale. I've seen it work in production. And how do costs go? Because as you scale, the costs go up for Firebase. Well, it has a lot of plans that you can, with different data quota that you can use. The good thing with Angular and Firebase is that because Angular is from its nature made to support large applications, so it works very well with Firebase, and because you get all the power from the observables, you can really be very efficient in getting new data. And if you have an application that has a lot of dynamic data, then it works very well about that. Is it affordable? As I said, it has different quotas. And what about backups? Again, you can, if you have a lot of data, which most probably if you are scaling, you are going to have a lot of data. The good thing with Cloud Firestore is that you can actually schedule Cloud Functions to run at certain times. So you can, with the Google Cloud Scheduler, you can create like a cron job that will run nightly and back up all your data so that you can be safe. So since we were talking about serverless and cloud, some takeaways. Solutions like that and Firebase can help you create full solutions for your web pages, like hosting, scheduling jobs, manipulating data, sending notifications to users. You can find pretty cheap or free solutions in the various cloud services and namely Firebase. And Cloud Functions are awesome because you can send notifications, you can create your custom queries, and you can back up data, and you can do anything you want. Angularfire is awesome because it creates all these bindings with Firebase, and you get your observables, and you get anything you need. And that's it, I guess. And these are my slides here. And here is the code for my demo, but you can copy the slides and copy it from there. And if I have time, I can take questions, I guess, or I don't know how it works.
Sure.
Okay.
Contemplated questions, but if anybody's got a question for Katerina, yeah. I will take silence as no.
Okay, everything was crystal clear. I'm so happy.
Fantastic job, Katerina.
There were actually, in the chat, there were a couple questions.
Oh, there were.
Yeah,
I'm going to look.
Katerina?
somebody asked about the Angularfire auth guard when that was added.
Do I recognize that voice?
Oh, you do recognize that voice.
It's the Jeff Cross.
I wasn't looking at the chat, sorry. And I think in a couple of months, I'm going to have an actual online training on Firebase organized by this dot, where I'm going to go deep in all these things that I lightly touched today. It's going to be a full proper training, and maybe you can join, I guess, if you're so interested in Angularfire and Firebase. And yeah, let me see the chat.
The only other question was about using Firebase and any other databases together.
So interesting. Right now I'm working with a client and we're using Firebase with AWS and Dynamo. I guess they work okay. But the thing is, I mean, the problem we run into with Dynamo is that the data you get back is not synchronized like in real time as you get in Firebase. So, for example, in Firebase, the moment you make a change, you get this back. In Dynamo, it didn't exactly work like that. So we needed to write lots of different code to handle both situations and make sure the experience for the client is the same. I don't know if that answered your question. What's the best way to stay updated with latest libraries and Angular utilities? I mean, stay updated in using them or learning about them? I mean, I learn about them from friends or from Twitter or from communities I'm part of.
Yeah, it's definitely community. Be a part of, go to local meetups, go to online meetups. Follow Katerina on Twitter, follow Jeff on Twitter.
And yeah, and the way I try to stay updated with the actual technology is that when a new version comes out, I try to test it on one of my side projects and see how it works. Or like make a pet project with it, just for fun to see how it behaves. I don't know. Let me stop sharing.
Good. Anything else?
How do I stop sharing?
I see I use Renovate Bot to stay updated. And I have any known advantage against something like MongoDB.
I have no answer to that.
Okay. Is Angularfire always supported by Google?
I cannot answer that either, I guess. Oh, I just noticed it went dark outside as I was speaking, right? I started off with day and now it's night.
All right, well, thank everybody. I'm gonna just do, hold on right quick. I'm gonna do one more just to show you our online events coming up, and hold on. So one more plug for this dot. It was our sponsor today, and we really appreciate everybody working and putting this together. We are a tech consultancy, and if you need help with front-end and JavaScript, we'd love to chat with you. And this is just, again, looking at our upcoming events. We have React Online on August 8th, GraphQL Contributor Days on August 8th. Also this.JavaScript State of Frameworks on August 13th, Vue Online on August 15th, and Web Components Online on August 22nd. So thank you guys very much. We really appreciate it, and we'll talk to everybody soon.
Thank you.
Have a great day, everybody.
Have a great day. Bye.